Hi class, I wanted to follow up my lecture on the fundamental theorem of calculus. Okay. Okay, which was this. When you integrate from a to b of f of x dx, this was equal to f of b minus f of a. And what we said was we used this to find the area under the curve. Okay, we used it to evaluate a limit involving a Riemann sum. And so what you're going to notice sometimes when you do your problems is, what does it mean? Okay, what is the context of it if you work this integral and get a negative number? Which can happen, So I want to do an example, okay? So here's the example that I wanted to work. Let's integrate from 0 to 3 the function x squared minus 6 dx. And so look, when you integrate this, right? So x squared integrates as x cubed over 3 minus 6x, and I'm going to evaluate from 0 to 3. So the fundamental theorem just says, look, let's plug in 3. So this is 3 cubed over 3 minus 6 times 3 minus, now plugging in 0. 0 cubed over 3 minus 6 times 0. Well, look, this goes away because that's just 0. This ends up, a 3 will cancel. This ends up just being 3 squared minus 6 times 3. Well, this is weird. So this ends up being 9 minus 18. So we end up getting negative 9, right? And I want you to know that that's okay. All right, so it's okay to get a negative result. So let me sketch the region here and explain why you're getting a negative result here. One, two, three. 1, 2, 3, 4, 5, 6. So this isn't perfectly drawn to scale here. So you're integrating from 0 to 3, right? So if you plug in 0, you get minus 6. You plug in 1, you get minus 5. You plug in 2, right? 2 squared is 4 minus 6, you get 2. And then when you plug in 3, you end up getting 9 minus 6, which is 3. So look, this is the area here, all right? And so notice we said that this helps find the area between the x is equal to a and b and above the x-axis. But do you notice how like a lot of this area here is actually below the x-axis? That's why you're getting a negative result here, okay? Because this integral is actually finding some area where you're under the x-axis instead of above it, and that's all. And it's perfectly okay to get a negative result here when you evaluate here this fundamental theorem of calculus as such. So when I just wanted to do this follow-up example, so that when you're doing your homework, okay, or an exam, and you get a negative result, it's perfectly okay. It's perfectly acceptable to do.